Hello class, Professor Anderson here. Let's take a look at an example problem of a boat crossing a river. This is one of these relative motion problems. And let's say that we have the following scenario. We have a river that is flowing in this direction. Here's our river. And we'll call that speed of the river, VRE, speed of the river relative to the earth. And now we got a boat here, and we want our boat to go straight across the river. Okay? If our boat's going to go straight across the river, should I point my boat directly across the river? What do you guys think? Probably not, right? Everybody knows that if you point it straight across the river's going to carry it downstream. So we can't point our boat in that direction. We, in fact, have to point our boat upstream in this direction. And we need to figure out what direction I need to point the boat and how fast do I have to move the boat in order to get straight across the river. Okay, so here's our two relative velocities. We have the velocity of the river relative to the earth and the velocity of the boat relative to the river. And let's give you some numbers. Let's say that the speed of the river relative to the earth is 5 kilometers per hour, and it is heading east. And the velocity of the boat relative to the river, the maximum speed that it can do is 10 kilometers per hour, and we don't know what the angle is yet. Okay, so RV means river relative to earth, VR means boat relative to river, and we want to find what is the speed of the boat relative to the earth, and at what angle do we need to orient it, namely this angle right here. Okay. And the goal is to go straight across the river. That's the caveat here. Okay, there's a couple different ways to think about this problem, but one way to think about it is the following. We can just draw some vectors. This is the vector of the boat relative to the river. This is the river relative to the earth. And if I add those two up, it looks like I will get the velocity of the boat relative to the earth. This is the right angle. This is our angle, theta. And I think that's just about all the information we need. And now look, we've drawn a triangle. We know that Pythagoras holds for this right triangle. We've got a 5, we've got a 10. We can solve this for VBE. VBR squared equals VRE squared plus VBE squared. And now we can solve this for VBE. VBE equals square root of VBR squared minus VRE squared. And we know all those numbers, right? We've got 10 squared. We're going to subtract 5 squared. That's the square root of 75. And we did this earlier. Square root of 75 was 8.66 kilometers per hour. All right, so that's the first part. Before we think about the second part, theta, is there some other way we could do this problem? Anybody have another thought on how to do this problem? Anybody? Okay, Ian, yeah, what do you think? How else could we do this problem?
I would use trigonometry.
Okay, so what would you do with trigonometry?
I would take the velocity of the boat relative to the river and either use sine or cosine.
Okay, excellent idea.
Yes.
Let's try that. Okay, so Ian's suggesting that we go back to the original picture and we do a little trig using sines or cosines. Let's try that, right? VBR is pointing up like that, which means there's two components to it, right? There is some component in that direction, VBR, we'll call it Y, and there is some component in that direction, VBRX. This one is, of course, the sine component, if this is theta. This one is the cosine component. So this is VBR sine of theta. This is going to be VBR cosine of theta. And if we're just thinking about the speeds there, we can go like that. All right. If I'm pointing this thing slightly upstream, then my component here upstream has to be what if I'm going to end up moving straight across the river? It has to be exactly the speed of the river. Right? Whatever component of the velocity of the boat going upstream, that has to exactly match the component of the river going downstream. And so our condition now is the following. VBRX has to equal the speed of the river going downstream. Right, that makes sense, right? If I turn my boat all the way upstream such that I was going upstream at 5 kilometers per hour and the river's going downstream at 5 kilometers per hour, I wouldn't go anywhere, right? We would be exactly still. And so whatever component I have going upstream, as long as it equals the velocity of the river, the speed of the river, then any remaining vertical component is just going to carry me straight across the river. All right, so look, we've got VBR times the sine of theta equals VRE. And now you can calculate theta. Theta is the arc sine of VRE over VBR. And so using trig, it allowed us to, in fact, first get theta. And once you get theta, then you can go back and calculate this quantity, VBE, the velocity of the boat going across the river. Okay? Hopefully that's clear. And if you want to plug in the numbers, you can double check my answer. We got a theta of, I think, 30 degrees. All right. Any questions about that one? All right. If that's not clear, come see me in office hours. Cheers.